Hi everyone. In this video I'm going to go over projectile motion. So imagine you throw a baseball or kick a soccer ball into the air. These would both be examples of projectile motion. So projectile motion is if you throw something into the air and the object only experiences an acceleration due to gravity pointing downward. Right? So if you throw an object into the air and it only experiences an acceleration due to gravity pointing downward, this is an example of projectile motion. So let's take a look at an example here. So a baseball leaves the pitcher's hand traveling at 180 kilometers an hour, horizontal, toward a batter 18.5 meters away. So let's try drawing this out. Right, so the pitcher throws a baseball, and you can kind of imagine it's going to follow this path, right? It's going to look something like this. We know, right, they threw the ball at 180 kilometers an hour. And we want to figure out here, how long will it take to reach the batter? So this motion we're looking at here, we're going to have two components. There are two components to this motion. There's a horizontal component, right? A horizontal component going left to right. And then there's a vertical component going up and down. Right, so here we're going to need to consider these components separately. So the horizontal component here, when you're dealing with projectile motion, it's always going to be in uniform motion. So the horizontal component here is always going to experience uniform motion. Right, so that means we can use our formula, speed is equal to distance over time here, to help us solve this problem. So let's write down what we're given. So we know the speed the baseball is thrown at horizontally, right? It's thrown at 180 kilometers an hour. Which is the same as 50 meters per second. So you can use Google to check this, or another way you can do this is just divide by 3.6 to go from kilometers per hour to meters per second. We also know it's going towards a batter that's 18.5 meters away. So the distance is going to be 18.5 meters. And what we're looking for is how long does it take? So again, since we're looking at uniform motion, or we're just considering the horizontal component here of this motion, we can use the uniform motion equation, right? Speed is equal to distance over time. And we can rearrange this equation to solve for the time. All right. So we already know the distance, we already know the speed, so we can just plug that in. And when you do that, you get 0.37 seconds. So it takes the baseball 0.37 seconds to reach the batter. Part B. What is the vertical drop of the ball from the moment of release to the batter's box? right? So like I said before, there's really two components of this motion, right? We have the horizontal component here, which we just considered, and we have the vertical component of this motion, the up or down component. So here, the vertical component, whenever you're looking at projectile motion, the vertical component will always experience uniform acceleration due to gravity. So the vertical component is always going to be uniform acceleration. So let's take a look at this now. Let's see what we're given. So and again, just remember, we're looking at the vertical component of the motion now. So since this ball was thrown horizontally, that means the initial speed, right? The initial vertical speed is going to be 0, right? There won't be any initial speed in the vertical direction because the ball was thrown horizontally. Well, what else do we know? We know the acceleration, right? The acceleration due to gravity is 9.8 meters per second squared pointing down. So let's write that out, right? The acceleration is going to be negative 9.8 meters per second squared pointing downwards. And we know how long it's going to take, 0.37 seconds. And what we're looking for is the total vertical drop, right? What distance does it drop? So we're going to need to use one of our uniform acceleration equations here. So if you look at this, you'll notice I'm not given the final speed, and I'm not trying to find it. So this tells me I'm going to want to use my final velocity independent formula. Right, I'm going to want to use this formula right here, because this is the only one that does not include the final velocity. Okay, and now let's just plug everything in. So we know the initial speed is going to be 0. We know the acceleration is negative 9.8. And we know the time is going to be 0.37 seconds. And you can just plug this into your calculator, and you'll find the total distance is negative 0.67 meters. So that means that the ball will drop 0.67 meters. So in summary, when you're looking at projectile motion, right, we want to consider both the horizontal and vertical components of our motion here. The horizontal component, the left or right component here, will always experience uniform motion, whereas the vertical component, the up or down component, will always experience uniform acceleration.